Okay. For examples 2 and 3 in the book on page 422, I'll let you guys look at those on your own, but I'm going to pick some from the book, and we're going to try them out. So let's start with problem number 5 on page 423. And make sure you read along with me here. It says, Bruce has $5.50 in dimes and quarters. He has 8 more quarters than dimes. How many quarters does he have? Okay, so again, we can make our dimes and quarters chart. Dimes, quarters, number times value of coin equals total value. Alright, so again, we're going to use 2 variables and come up with 2 equations here. So we have dimes, quarters, 10, 25, oops, that didn't look very good, 10D and 25Q. I mean, once you have 2 different variables, the chart kind of fills itself out a lot easier. Whatever is unknown, you just put a different variable there. Obviously, the value of coins is easy, and total value is easy because you're just multiplying. Okay, so now we just have to get to our equations. To get to the equations, again, I just reread the problem. Bruce has $5.50 in dimes and quarters. Okay, that's a value thing. So value equation. So I have the value of dimes plus the value of quarters equals $5.50. Again, we're using cents and not dollars. Okay, the next piece of info in the problem says he has 8 more quarters than dimes. Well, this is a number of coins and has nothing to do with value. Okay, so we have to take all the value out of that. No 10, no 25, no total value. It's just straight up number of coins. So he has 8 more quarters than dimes. Okay, so 8 more quarters than dimes looks like dimes plus 8 equals quarters. So he has 8 more quarters than dimes. So there should be more quarters than dimes, which we'll work out with this equation. So now we want to solve this system. Equation 2 looks like it's already solved for Q, which is nice. So let's plug that right into equation 1. So here's equation 1, and we have 10 times D plus 25 times Q, which was D plus 8, and that's going to equal 550. Now we simplify and solve. 10D plus 25D plus 200 is going to equal 550. Now we have 35D. I'm going to subtract that 200 right now and get 350. Let's do some division. That doesn't look too bad. D equals 10. Now I'm going to plug that right into equation 2 because it looks pretty easy to do so. 10 plus 8 is 18, so we know that Q is going to be 18. Okay, now I'm going to double check with the words of the problem again. It says Bruce has $5.50 in dimes and quarters. Well, let's see, we have D equals 10, Q equals 18. 18 quarters is $4.50, and 10 dimes is $1, and that looks like $5.50 to me. Then I'm going to read the next part. He has 8 more quarters than dimes. Sure enough, that's pretty obvious that that is the case. So we have a correct answer, 10 dimes, 18 quarters. I'm going to pause this for a moment. Okay, the next one we're going to work on is number 10. So read along with me there. It says the length of a rectangle is 5 centimeters less than 3 times its width. If the perimeter is 70 centimeters, find the dimensions. Well, being that they say the word rectangle, immediately I think, well, I should draw a rectangle, because that makes a lot of sense. Okay, so length and width. I use a big L for length because a small L looks like a 1. Since we're also talking about perimeter, you might even consider labeling every single side. And in the past, we would have labeled one of the sides as like 3W minus 3 or 3W minus 5. But here we can just start with W and L because we know how to do two variable equations now. And it's easy to label there. So now we can read the first sentence. The length of a rectangle is, so the length of a rectangle is 5 centimeters less. Oh, okay, so that means 5 less than something. I don't know what that something is yet. 5 less than 3 times its width. All right, 3 times its width. There we go. That's our equation number 1. Remember, if we have two variables, we must have two equations, or we won't be able to figure out what the letters are. So the second sentence of the problem says that if the perimeter is 70 centimeters, okay, well, that's not bad. We know that L plus L, or 2L, plus W, or 2W, equals the perimeter, which is 70. Now we have two variables, two equations. You're probably already noticing that equation 1 is already solved nicely for L, so let's plug that right into equation 2. So we have 2 times 3W minus 5 plus 2W equals 70. Let's simplify and solve. So we have 6W minus 10 plus 2W equals 70. I'm going to combine the W's. I'm going to add the 10 in the same step. And now we can divide, and we get 10. Now plugging that back into the first equation looks simple. You could do it into the second equation, but the first one just looks so much easier, I think. So L equals 3 times 10. And in this instance, you could probably even do that mentally. So L is going to equal 30 minus 5, so L is going to equal 25. That was interesting. All right, let's move that back under here. Don't know what happened there. So L is going to equal 25. So I think W is 10 and L is 25. So I'm going to go ahead and put that up here. 10 and 25. And let's read the problem again and see if it makes sense. So the length of a rectangle is 5 centimeters less than 3 times its width. Well, 3 times its width would be 30, and 5 less than that would be 25. So that first statement is true. And then the perimeter is 70, so 25 plus 25 plus 10 plus 10 is 70, so that is a correct answer. And we can move on to the next problem. Pause this video for a moment. Alright, I'm going to end this video here, and then I'll try one more example for video number 3.